Welcome to Talk Design Podcast, the space where creativity meets conversation. I'm Adrian Ramsey, your host, and as someone deeply entrenched in the world of design, I'm thrilled to introduce you to the minds that inspire me, in the hope that they will spark something special within you too. From a design past crafting women's swimwear to pushing the boundaries of performance sportswear, from mountaineering to international yachting, to implementing systematic innovation solutions that transcend boundaries in aerospace industry. My heart remains rooted in architecture, and exploring the emotional tapestry woven by built spaces is my fascination. My journey in design has been what can only be described as a life of design. I want to thank you for lending me your ears. I'm eager to embark on this next episode together. My guests on Talk Design today are Michael and Joss from SIREWALL. Now, SIREWALL will take a bit of explaining, but I'm not going to even try and do that. What we're going to do is dive into a journey of rammed earth, which has America, Canada, Australia, New Zealand, and beyond in this journey. And I was lucky enough to meet these guys through Mercedes and her company, which is a construction company in Texas who does rammed earth. And we're yet to release her podcast, so it's not much point in us talking about her. She didn't turn up. So anyway, her podcast will be coming out soon. But I wanted to bring these guys on the show because these guys are kind of the world's experts in insulated rammed earth products. Rammed earth, of course, has hundreds of benefits. And I've got all kinds of questions I want to ask the guys about it, not just about construction, but living with it, etc., etc. So sit back and enjoy. We've got this on YouTube as well. We're going to share some photos along the way. So if you've got time to watch it on YouTube and you'd like to see what we're talking about, that would also be available to you when we've released the podcast. Guys, welcome to the show.
Thank you very much.
First of all, just make the note that one of you is in Salt Spring Island in Canada, which is a little island up in the Pacific Northwest. And then the other of you is in Phoenix, Arizona. So, these guys work together. They're not necessarily in the same room or in the same town at the moment. Yeah, who wants to kick off and tell me, the fairy tale story of how you got to understand rammed earth, and then, like how you kind of fell together in this story as well, where you guys kind of met, what happened. But start with, you were little guys and you were building. I don't know what you were building. You were kids playing with blocks. What happened from there? Who's going to go first?
Joss should tell the story.
Yeah. I'll start until...
His dad invented SIREWALL, so he should start.
So he knows the truth. Yeah.
Yeah, I'll go through the background and then Michael will jump in and take over from there.
Cool.
So I grew up on Salt Spring Island where I live today. And my father he was born in the early 50s. And he was a boat builder, environmentalist, and then went to school as an energy systems technologist and really always wanted to understand how things work and how we can do them better. So he worked for the Canadian government through the energy crisis, created inventions to support the Canadian government on how to do things more energy efficiently, and then moved back as the energy crisis in North America went away. No one cared about it anymore.
So was this around 75 kind of thing?
Yeah, that would have been late 70s. People stopped the energy crisis. We had different governments come in, and then the energy crisis was no longer a crisis. And there wasn't funds for that, wasn't a priority. So my dad went back into construction. And from there started out doing renovations, stick frame, which is how buildings get built here. And seeing how those buildings, as building codes changed, how they weren't aging well and how people were getting sick inside those buildings. And he wasn't proud of what he was doing. He was trying to do it as best he could. He was studying like he does as a technologist, and it wasn't happy with the results. So at this point, we're in the late 80s. I was born in 85, and he took a couple of years off building and traveled the world, looked at how people in different cultures built and what was the best way to build in North America, in our part of North America, where we're in a very high seismic zone, earthquake zone, cold weather, rain, what would be the best way that we could build in this climate? And that took him a couple of years. He describes it as the most depressed time in his life, where he just, he was at a loss and felt like his life work wasn't amounting to much. There's a lot of pride in that.
Yeah, right.
So from there, he came to things need to last longer and they need to be healthy. And earthen buildings historically have been the best at that. So then he started looking at what are the failures of earthen buildings in today's environment, and they don't get built in cold climates. They don't insulate well. Rammed earth isn't very strong. So that was in 91, my dad started building with rammed earth. And shortly after that, he went to Australia, met with Stephen Dobson and Giles Honan, who popularized rammed earth in Australia. Went and met with David Easton in California, who popularized rammed earth in North America.
Made it good.
In California. Yeah. And then from there, he took it back, and none of them could tell him how to build it in cold weather, how to make it insulate well, how to adhere to our building codes. So started inventing from there how to make it strong. That was the path.
But he did that from Salt Spring Island.
Yeah, I was born and raised as an environmentalist on a small island. How do we do things the right way with a strong moral compass, and all decisions going through what should be done, not what's easiest or what is done.
Yeah, right. So he was a guy that was like beyond passionate about finding a solution for it, but based off human health within the built environment.
For him, it started as being an environmentalist, energy use, believing that we were destroying the planet he loved. And from there, looking at our communities and looking at cancer rates skyrocketing and all these people who he had grown up with getting sick and passing away, or someone in their family passing away, and people in our family passing away. And I started working on construction sites in the mid-90s just as a cleanup guy, and we had a brilliant carpenter who got cancer and died. And there used to be a site that you could look up the causes, what the different materials that were used, and then what that was known to cause. It's called scorecard.org out of California.
What was it called?
It won't help you, but it's scorecard.org.
The reason that caught my eye or in my ear was Scorecard. A friend of mine, a guy called Daniel Priestley, has a business called Scorecard, but it's not .org. It's a way of, anyway, it's a different business, but he's based out of England. It's a global business, but yeah, scorecard.org.
Yeah. So it was an amazing site. You could look up all the paints and varythings and everything that he was using, and it would tell you what health issues that was known to cause, what kinds of cancers, what kind of illness. And so my dad did this, and it was direct correlation. You could see what this guy spent his life doing and what it caused. And he passed away in his late 40s, I believe. Yep. And we're a small community. It hit my dad hard. Mm-hmm. And so why are we building with all these chemicals? Why are we living with all these chemicals around us? And again, the underlying consistent approach of how do we do things better?
Yeah, that's awesome. He's a real, I was going to say like evangelist for it, but it's just a total way of life. It's a total way of going, I have an opportunity to make a difference, and therefore the difference somebody's got to pick it up. So he picked it up.
Yeah, and it's not the easiest path, but for him, it was the only path. And so going back, the solution for him was rammed earth, but I need to insulate it. So we tried all different ways of insulating it. We started building, and we built Randy Bachman's house, was the first Bachman Turner Overdrive, had a number of hits. But
he's a musician.
Bachman Turner Overdrive was a big band for me when I was growing up. I loved them.
Yeah, so they really
woman,
helped us get
taking
going.
care of business, all those songs.
Yeah, absolutely.
So they really got us started and financed a lot of that early research, and we built their home and a barn, which became their recording studio. And from there, we really just kept going through the science of it, and we stayed on our little island from the mid-90s until about 2005. And then we started getting asked to go away for commercial buildings. And at that point, we started running into issues with how we currently did things, where we weren't building strong enough. So what differentiates SIREWALL is we build way stronger than anyone else. We don't build anything less than 20 MPa. Most rammed earth is around 4 to 6 MPa.
Yeah.
Maybe 10 if other rammed earth builders are doing it well. And we insulate. We were the first people to color, use iron oxide pigment in rammed earth. So we've developed methods of making it mainstream and up to today's building codes throughout the world. So that's a long story short. Myself, I got involved because of the health issues that I saw in my community, people who I loved dying and wanting to make a difference. So that's what you're sensing as health being the basis of our company. That came a bit later from Michael and I, and I'll let Michael take it from there.
Yeah.
Michael, how did some Australian bloke, I kind of know a bit of the backstory, but end up with rammed earth and then better still with SIREWALL? What happened for you? And Ted, you traveled a lot, so yeah.
I traveled a lot. My parents, we moved a lot when I was a kid, and after I left home, I traveled a lot too. I've lived in Canada, I've lived in Europe, and lived in America now for about 20 years. But I met actually Joss's dad and mum through an education company that I was running in Canada. I ran a company in Canada, and I ran the west coast of Canada for that company, and they participated in some of those education programs. And I'd never met Joss before, and then I moved away from Canada. I left Canada in 2005, moved down here, and I was never had a construction background or anything like that. But I got started in construction because I really loved gabion walls, which are wire baskets filled with rock, landscape walls mostly, retaining walls and that sort of thing, roadside retention. So I started building one of those for myself, and everyone, you couldn't find them around here. They're not very big in America, or they weren't. And I started building one, and everybody said, "Where'd you get it? And can you build me one?" And all this. So I started a company, and a few years later, I was like, "Oh, I want to do something else." And kind of, that was going well, and started looking around for something else to add to that business. And I kept coming across rammed earth, and then I started looking for who's the best at it and who can train me, and do I have competition, and started finding SIREWALL and seeing SIREWALL was the best all the time, and they had the strongest rammed earth and so on. So I looked up the website, and I was living in Arizona at the time. I looked up their website, and it's a very serendipitous kind of re-meeting, I don't know, reconnecting, but looked up their website and looked at the contact page, and there's, Joss's last name is Krayenhoff, and you can't miss that name, Yeah.
There was only a few of them.
Yeah, exactly. And his dad's name is Mira, and the contact page was Mira Krayenhoff. And I remembered him from the education company I ran in Canada. I was like, I know this guy. And so I emailed, and Joss emailed me back. I said, can I connect? And, I've moved to Arizona. I don't know if you remember me, and, all that. And Joss emailed me back and said, look, Mira's really busy. My dad's really busy. He'll get back in touch with you in about 2 weeks. And I said, okay, great. So the phone rang one day. It's about 2 weeks later, and it was Mira on the phone. I said, hey, do you remember me? It's been about 10 years, and I used to live there, and I'd really love to learn what you do. I'll come up to Canada. I'll learn, what do you want? I'm really enthusiastic about some things that I want to learn, and I said, I'll intern or whatever, I just want to learn, can you teach me this? And he said, and I said, I'm in Arizona now, so I'll come up, no problem. And he said, oh, we were just down in Arizona in this quirky little town. We got a project coming up there in a few months that we're going to be out there for a while. And I said, well, it doesn't matter where it is. If it's 2 hours away from me, I'll come out, I'll intern, I'll volunteer. I don't care. I just want to learn, just, can we do that? And he said, yeah, just let me look up where this town is. The name of this town. It's this quirky little town. He says, I'm like, okay, fine. So he looks it up, and he says, the town name is Cave Creek. And I live in Cave Creek.
No
and I
way.
did live in Cave Creek at that point. And I was like, okay, we're going into business together.
Yeah, right. Yeah,
and I ramped up. It was just like, it was done, So they came into town. It was a very big residential project that I wasn't allowed to visit initially. So I just started supplying them with labor, with people I knew who could, build for them, because they all moved down here from Canada to do this project. So they didn't know anybody and didn't know where to get people and good people and that. And I did. So I started sending them people, and eventually they invited me up, and I started hanging around, and I started learning, and they started inviting me to do more. And then the size of the project doubled in in size, but also doubled in time, and they didn't want to stay down in Arizona much longer. So they said, well, look, we can make you the project manager. We'll go into business together, open SIREWALL USA, and we'll be partners, and we'll mentor you and support you with this project. And I come from a bit of a project management background, so it kind of fit for me anyway. And I took over that and ended up being the project manager. My first project was being project manager on one of the top 10 largest homes in America, which is 70,000 square feet. It's massive. It's like a compound. It's ginormous. I don't know what that is in square meters. It's a big house.
Yeah, a lot.
Yeah. I
70,000. Yeah, it's divided by 9, basically, isn't it?
Yeah, something like that. Yeah, it's massive. So,
and also
a large part of it, rammed earth glass, is a little bit of stick frame infill, that sort of thing. But there's approximately 55 SIREWALLs on there, and they're all, a good portion of them are 25 feet tall, 30 feet long, and there's some other smaller ones that are pillars and different things, with windows in between.
Yeah, wow.
Yeah, so it was a good 2 years of my life, maybe more. And you can see that on our website. The house, the resident's name is called Strata, and you can find that on our website on SIREWALLUSA.com. You can find that. And there's a video and stuff, kind of shows you that whole home. So that's how I got started. And now I run the operations for the US. I'm starting to get a little bit involved in some of the international stuff as well. I'm based in Phoenix, so it makes sense for me to run the US.
Yeah.
And now we've got projects all over the place, all over the US and some different parts of the world as well.
It's pretty exciting, eh? Like like the journey, and also the, serendipitous moments of, what do you mean? I'm in, Cave Creek. Yeah. What do you mean, Cave Creek?
Yeah, you just happen to be having a project when I want to learn ramp come into Cave Creek. Well,
exactly.
Yeah, okay. Yeah. Let's do it.
And for yours, going from gabion baskets, as a method of, often I see, as you say, retaining walls. Certainly in big commercial stuff, there's lots of it. I was in New Zealand, down in the Queenstown, Wanaka area on a couple of months back. And the masses of it along the river sides and stuff like that to retain walls or retain hillsides and stuff. And then there's a wonderful project here on the Sunshine Coast that Bark Architecture did, where they used these beautiful gabion walls, not just filling baskets with rocks, but placing rocks in baskets would be a better way of describing it.
Yeah, you can do a lot with those. Very creative and lots of things.
Yeah, exactly. A really beautiful building method, but obviously not for, it is structural, but not for a house, because, if the air blows through it, the water runs through it, all those things.
That's right. Yeah, they're a permeable wall. They're not really structural. They can be made structural, but you've got post and beam inside them to make them structural. But not really used other than a facade on the outside of a house, maybe, or something like that. Nothing comparable to rammed earth or SIREWALL. That's for sure. They're completely different building products.
Exactly. Not even really the same customer.
No, very different customers. The only thing that's sort of similar is they're both walls.
Yeah.
And so that gave me a little bit of insight into what I needed to know to deliver on SIREWALL and deliver on projects for SIREWALL, but very little. Yeah, I learned. I went in pretty green and learned. I try to be a sponge when I'm take everything in.
Obviously it works, that part, but obviously no issues. There's plenty to learn about it. So I want to dig into the rammed earth part, obviously, because my experience of rammed earth is designing a few projects with it, and got one on at the moment, which I'm doing with it. And then this whole thing between, it's just a mass wall. And, Josh, you were saying, maybe it might have, a PSI of 10 versus, something really heavy, like something, really high in its structural intent. And then also the piece around the insulation, obviously, which is SIREWALL, but that understanding where and how and what works best and why it works best, and why you would not just build it traditionally, why you would go and build it with all those pieces. So go for it. To give me, and I love, we will dig right back into the whole health aspect of it as well for the human, because that piece with, you know, a lot of this shift that we're seeing. I'm going to credit COVID for a big part of common understanding of that. I want to get into, you know, what the biohackers are doing, why they want to live in it as well, what happens with all those things, back to the intent that your dad actually started it with, and going, okay, this is a big piece. And I think that that's beyond the technical side of what can happen. It's actually what makes people healthier, live better, more joyful lives, creates a better inhabitable space for humans, but also I want to go beyond that to even what it does for animals and things like that as well. So I don't know, you guys tell me the story.
Sure. Do you want me to jump in, Joss, and go start a little bit?
Yeah, sure. There's a lot to dig into there, so you can
a lot to dig into, but just, you know, just so people understand the differences between traditional or other people's rammed earth and SIREWALL, I'll just give you some basic differences. There's a lot.
So start first with what rammed earth is, because, you know, people will go, for people who don't know it, they'll be going, what the hell is it? Is it bricks? Is it like mud brick? Is it, you know, like straw bale? These other, let's call them alternative building methods. I have a bit of a laugh about that because my kids went to a Montessori school, and there's more Montessori schools around the world than there is schools in, you know, Queensland. Yet we follow the Queensland curriculum, but Montessori's curriculum is global. So yeah, like this alternative, but yeah, okay. People have been doing rammed earth for how many millions of years? Yeah.
Yeah, that's a good comparable, because there's more earth buildings in the world than there is anything else as well.
There you go. Yeah. The mass alternative.
Yeah.
Go from there. So give us a background on just what it is and why it's different from the others as well.
Why don't you do that bit, Joss?
Oh, sure. So earth building, I'm going to differentiate rammed earth from earth building first, and then differentiate within rammed earth. So earth building gets all thrown together, whether it's cob, straw bale, compressed block, which is what you like rammed earth blocks, or rammed earth walls. And those all, an earth ship was Michael Reynolds out of New Mexico. You know, all those kind of get thrown together. And the most of them are do it yourself. There's not a lot of technology in them. They're very effective at bringing community together and having community build a home for an individual or for a whole community. What they're not effective at is going through building codes, you know, adhering to building codes, adhering to quality control standards. You know, these are things that are done in the middle of the bush typically, that, you know, sometimes they work well, sometimes they don't. Their issues are highly publicized, so are their successes. So that's earth building. Rammed earth is a little side shoot of that. And rammed earth is, when people say earth, it means something completely different to a farmer than it does to a geotechnical engineer. It's actually opposite. Earth to a farmer is organic. Plants grow from the earth. And when they say that, they mean topsoil. Earth to a geotechnical engineer means everything under the topsoil. Right. So the earth, you have the topsoil, which is a very thin, average on the planet is about, it's less than the skin of an apple. Like if you were to take blow it up. Yeah, right. You know, that thickness, everything grows from that topsoil. So this is the environmentalist background. That's the stuff of earth. I mean, the stuff of life.
Yep.
And if you take away that topsoil, that skin of the apple, none of us survive. You know, we are that topsoil. We're a part of that.
Yeah.
We're organic. And whether a tree's standing up or lying down, it is that topsoil. Okay. So that what we build, what rammed earth is everything underneath that topsoil. So it's silts, clays, might be sandstone, basalt, granite. You know, there's any number of, you get into geotechnical engineering and analyzing what those aggregates and sands and what the chemical compositions are of that material. And so that's what rammed earth is built with. If you put organic in your rammed earth, topsoil in your rammed earth, it will expand, it will blow apart, and you will have holes in your wall. It won't work.
Organic. I think I've seen a Frank Lloyd Wright project like that. Yeah, carry on.
Yeah. And there's a lot of rammed earth projects like that. This is in the do-it-yourself community without standards world. So from there, now we're in rammed earth. It's inorganic. You're taking it from under the ground. There's stabilized and unstabilized rammed earth. So stabilized rammed earth means that there's cement in it. This is bringing us up to current codes, building to condition to today's standards. Unstabilized rammed earth, Krayenhoff is the biggest firm out of France. They do a lot of volunteer work, and they're a nonprofit. They do a lot of work in Africa, and they're really passionate about unstabilized rammed earth. So if anyone wants to go down that rabbit hole, I would suggest Krayenhoff is the Kraterre is the resource for that. That's not what we do, and that's not what the builders in Australia do either. Stabilized rammed earth typically uses about 10% cement and blends with the aggregates and sands that for a lot of rammed earth is found on the construction site. But we don't do it that way. So that 10% cement gets mixed with sand and aggregate, gets thrown in a wall and gets compacted. And you take that to a lab. And I don't know if you said PSI, I said MPA.
Yeah, we go MPA, whatever.
That's compressive strength.
Yeah.
It doesn't matter. I talk both.
Yeah.
But if you are using site material and you're not doing that soil analysis, the mix design piece, you could get anywhere from 1 MPA. It would be shocking if you got 6 MPA. You're building a very weak wall. Yeah. And it has a great story. You're using material from the site. We've done successfully with soil analysis. Like when we did a job in Pakistan, we used site material, but that was a city block. And they created a mine on the site to build the structure. It takes something to do that.
Yeah.
Whereas SIREWALL uses the same amount of cement, but we're using aggregates and sands from the region, still local, but there's all these quarries everywhere in the world. We found the best compacting materials in the region. We know we've done that because we're creating roads, we're creating bridges, we're creating concrete. People are using these compacting materials everywhere, and they have huge value.
Yeah.
So what we do is we go and we analyze all the materials in the region from all the quarries, and we find the best mix design that uses the least amount of cement to get the highest strength. And that's what.
Gosh.
So we're going and we're analyzing all the aggregates, all the sands. Yeah. We studied the U.S. Army Corps. They do this all around the world for concrete. So they go to name
everywhere.
Name everywhere. Yeah. This is what they needed to create a process where they could create a strong product anywhere in the world. So we pulled from that. We pulled from the Hoover Dam, which we toured, where they imported aggregates and sands from all over the U.S. and used a very small amount of cement to get a very strong wall that gets studied to this day as a mixed design marble.
Sorry, what was that?
It holds a massive amount of pressure too, the Hoover Dam.
Yeah, I was just about to say, why would have they given a rat's about how much cement they put in it? That's not the American way.
No, well, at the time, cement was this was a very poor time in American history when the Hoover Dam
was depression.
It's not not like it is today. So there were a lot of lives lost, but labor was cheap and cement was expensive. We weren't as refined in creating it as we are today. And they wanted to create a very strong wall, and they didn't care how much labor it took. It was actually good for the economy. So when economies go down, you actually look for projects governments look for projects that create labor.
Yeah, right. And so then they used very low amount. I didn't realize that about the Hoover Dam. They used a very low amount of cement to create a concrete wall. And so then that comes back to the aggregates that you're using. And if you take that approach to rammed earth and the refinement of the aggregates, you gain the strength.
If you
reduce the amount of cement.
Yeah, sorry. If you want to make concrete strong, what you do is you remove as much water as you can for it still to vibrate. If you have the concrete mix and you add more water, it gets weaker. You can trowel it better, you can vibrate it better. People like working it with it more when it's wetter. But if you want to make it stronger, you take out water. Yeah. Because the water, when it evaporates and it creates voids.
So like with us, we would run, any suspended slab would be 32 MPA. And if we can get away with cost-wise, we'd run it at 40 MPA, but concrete gets slightly brittle as it gets more. When I say that's still incredibly strong, but bristler when it gets stronger, but then also it becomes more waterproof. It does all those things along the way as well. So rammed earth.
So we achieve, long story short is we achieve the strengths of concrete. So we can achieved 20, 30, 40. We've achieved over 50 MPa.
Wow.
Replaced high strength concrete. And we do that through a mixed design of going and finding the best aggregates and sand that blend the best together. So if we have all one aggregate size and all one, so going back to concrete, because concrete's similar materiality.
Yeah.
You have your aggregate rock, which might be 5/8 inch rock. And that all that rock is between 1/2 inch and 3/4, or 1/2 inch and 5/8. And I can go to millimeters if that's easier.
No, whatever. Yeah. Biggest audience is the US for the podcast.
Sure.
So stick with inches.
Okay, good.
Yeah.
Good. So, and then you have your concrete sand, and concrete sand says that you need to have X amount of material within this size particle of sand and this size particle of sand, but there's a huge range that's acceptable. And then instead of doing a good with concrete, and then instead of doing in a proper mix design, what we would consider proper, they add 25% cement to cover their ass. And then they can achieve high results without putting that energy into finding what's best for that region. They can create high results everywhere in the world.
Yeah.
Whereas what we want to do is we want to find 3/4 inch rocks, 3/8 inch rocks, 3/16, 3/32, 3/64, all the way down to your silts and clays. Silts and clays are the smallest particles in sand. So we want everything in between, so that you can have large particles that are filled around them with slightly smaller particles, slightly smaller, slightly smaller. If you have large particles with large particles, you get voids. Nothing's weaker than a void. If you have large particles and then sand, your sand isn't as strong as a 3/8 inch rock would be.
Gotcha.
So this is the general philosophy of how we reduce our cement content and achieve the highest results anywhere. And we have a computer program that
you're not just making it up on the fly. You've kind of worked it out.
Process.
Very scientific process that takes it's a lot of work and a lot of technology and decades of refinement have gone into getting it to the point where we can hit, no matter where we go in the world or what materials are available, 99% of the time we're able to hit 3,000 psi or above. That's our in-house standard is 3,000 psi. And we've hit up to 8,000 psi before, and all using local materials and, less than 10% Portland cement for our thing. So what it means is you can replace concrete with our product. It means all the maintenance issues of rammed earth go away. You don't need to, we don't have dusting, for example. Rammed earth walls tend to dust, weaker rammed earth walls tend to dust. It means when you run your hand along them, particles fly off because they're weak. When we build ours, we don't have that issue. We don't need, so weaker rammed earth builders, not knocking anybody, but people who build, 1,000 psi need to seal their walls. Otherwise, you're going to have dust trail under your wall in the morning. Walls are not freeze thaw ready. You can't build below grade with weaker products, with weaker masonry products, all sorts of issues, right? Whereas SIREWALL is a complete wall system. You can build below grade. It's freeze thaw ready. No dusting, no sealing, no maintenance issues. It's a structural product. It's your exterior finish. It's your interior finish. It's your insulation. It's your vapor barrier. So we've got everything in one wall system that's going to last. It's been rated to last up to 1,000 years. And, so we've got sort of the ultimate product. We've developed, SIREWALL Mirror primarily has developed sort of the ultimate building product for being good for people, good for different environments, and good for the planet.
So on that piece of that, like, why do we give a rat's how much, cement we use? Who cares? Just use cement. We'll just do concrete. I've got my reasons, but I want to hear you guys.
Well, and to a degree, I actually agree with you, where the environmental industry has made cement the enemy and made concrete the enemy. And for me, it's actually, if you look at the buildings, my dad's family's from the Netherlands, Michael's is too, actually. Yeah. But when I go there, there's buildings 700, 800 years old, still in use, great buildings to this day. that's possible because they built with materials that would last a long time. What's concrete buildings make possible, what cement makes possible, is you do get longevity, you do get strength. And that is a very underappreciated perspective of environmental building. People think of environmental building and they think, how can I build it with the materials that take the least from the environment? I don't agree that that's environmental. If you're using more energy to heat that house, if you're having to replace the finishing, if you're having to constantly work on it, you're actually using way more energy and way more from the environment than if you built it right the first time.
I got roasted a few years ago, on, I added concrete as a environmentally not good, but in an environmental thing, why, use concrete. And I'm like, well, for dollar, performance, and it's a highly, what would I say, processed and mechanized process and understood, and we have batching plants close and we do all these things. If you actually looked at what it will do, if you look at it over a long period of time, it's a winner. It's an absolute winner. Does it have some issues? Absolutely, it has some issues, but maybe it's not the enemy we think it is. It's a partner in what we can use. It doesn't mean we should use it everywhere.
Right.
And concrete's, sorry, go ahead, Michael.
No, go ahead. I was just saying it can be improved, and they are trying to improve its environmental impact on it, with it.
They are, but not as they're trying to do it in a way that makes them look better. There's a way concrete can create mixed designs that use 6% cement.
Yeah, right.
Instead of 25% cement. That technology is out there, and the problem is that we're still competing on what's the cheapest way to build first cost, and that's a race. That's a race to the bottom.
Yeah. Something's got to give. Whether you're going to get the performance or the health benefit or whatever. So with concrete being, kind of, I suppose, the ecological side of it, it's like got its downside with the creation of cement, and we get the benefit of it. But like with that, what does that do for, if we jump into that kind of health side of it, what does it do for living in a lot of concrete? What does that do for the human versus, say, reducing the amount of cement?
Sure. So I need to make something clear about concrete. Concrete typically has a lot of additives in it that are very unhealthy, and those are sealants. Those are things that make you have more working time with your concrete or make it kick faster, or there's all these chemicals that get put in concrete that have health impacts. So I don't want anyone to take from this that concrete is a healthy material. The way it's typically made is not a healthy material. Those are getting released into your building, into your space. You're breathing them throughout the lifespan of that building. Yeah. That's bad.
I often liken it to, like you could go and cut a tobacco plant and make something, roll it in a leaf or whatever, and it will you're still going to put, smoke in your lungs. It's probably not a smart idea. But then you go to what they called a tailor-made cigarette, and they added a few things so that it would smooth out the process and just keep you coming back, And that's probably my kind of that thing of going, look, there's very different things with the same name in this picture.
Yeah. Oh, yeah. Yeah. So concrete is, I agree. Your analogy is perfect for cigarettes. And
rounder than concrete.
Yeah. It doesn't mean at its base. I mean, tobacco is probably not great for you, but it's not what the main issue is. You were asking about concrete buildings and living in concrete buildings. Yeah. Concrete is a high mass material. You typically put your insulation. There's a Oak Ridge National Laboratory. It's a really well established, respected institute in the States for testing, and Jan Kosny, I'm not sure how to say their name, did a ton of research on different systems, whether it's mass insulation, mass. So that would be what SIREWALL system is mass on the outside, insulation in the center, mass on the inside. That's our SIREWALL system. Or if you put mass on the inside and then insulation and then you stuccoed or plastered the outside. Sure. Or the reverse of that. If you put mass on the outside, then insulation and you stucco the inside, or you put drywall or whatever you put on the inside. And how does the performance work in each of these applications? And by far the best is going mass insulation mass. And Oak Ridge National Laboratory studied this in all different climates. You can go look at their research. We can send you the links if that helps.
Yeah, absolutely.
But they studied it in hot, humid, hot, not humid, cold, not humid, every different climate. And the best is mass insulation mass. And what that gives you is the mass will mediate the temperature. Mass mediates the temperature. It doesn't provide heat. It doesn't provide cool. It's a battery. People think that mass is a battery. Insulation is what prevents heat flow. Mass doesn't prevent heat flow. If you put mass in a freezer, it will freeze, and it'll stay frozen for a very, very long time.
Right.
If you put it, because it's a battery. If you put mass in a desert that doesn't cool down at night, or somewhere where it's 50 Celsius, or
it'll stay warm all night long.
It'll stay warm, and it will not cool down. It doesn't matter how much AC you pump into there, and it doesn't matter how much heat you pump into the freezer. That mass is going to take a very, very long time to change temperature. So mass is valuable, but it can also be a negative. And this is you were asking about rammed earth versus SIREWALL.
Yep.
What SIREWALL does is it creates two different envelopes. You have your outside temperature, which the exterior mass does have some benefit. It will mediate that temperature on the outside before it gets to the insulation. So your insulation isn't just getting pounded by your exterior temperature. Then your insulation is prevents heat from cool heat.
It could be hot or cold, from transporting into the inner mass.
Yeah. And then the inner mass creates an environment where your indoor temperature can stay constant. So we've had power outages in the middle of winter here without solar exposure for 4 days, north facing lot, which in our part of the world is bad. That's where the sun isn't in our part of the world. And the indoor they had a stick frame building on the property. Within a few hours it was the same temperature as outdoor. They had dogs living in the rammed earth house with two parents for 4.5 days, I believe it was, and it went from about 20 degrees Celsius to 16 degrees Celsius. So they lost 4 degrees of temperature over 4 days, letting the dogs in and out throughout the day. You've created something that holds its heat, holds its temperature constantly with anything that's happening around you. So and in today's climate, that can be fire. We can go all over the place with that.
Look, the thing I see is that we live in, I don't know what the human need for this is, but we love to look for extreme environments and populate them. Maybe they come with a lot of...
Some people choose to live in Phoenix.
Yeah, exactly. Right. Yeah, exactly. Rest my case.
It is madness. Yes.
But we do, as humans, we put ourselves in harm's way an awful lot, partly for the adventure, and it certainly comes with remoteness and beauty a lot. There's a lot of things that go with it. And with that, we're constantly pushing boundaries on where humans will live. They want to hang themselves off cliffs. They want to do all kinds of things. So with that kind of side of it, I find it pretty fascinating that we actually need technology, not to survive, because we could put on more clothes, we could do those other things, but to live at some sense of comfort in these environments for a period of time. And then obviously that reflects back on the energy usage that we use, what that takes. And then also on, we're going to get into this a bit further in a minute, but into the feel of how it is to live in these spaces. And, go back to that piece with, so we know that what you're doing with SIREWALL is mass insulation mass. I want you to dig more into just people understanding that, and then also about reinforcing it, because there's sort of that other school of thought where it's just, compacted. And that's the only one that I've really had anything to do with, is that school of thought. And I'd love to know more about, obviously the strength is incredible. There's a fair amount of labor content in rammed earth. So what you're getting is you're getting longevity out of that strength, but you're getting way more than longevity out of the strength. Take me on a bit of that.
To put that labor in without getting the strength, to me, is a shame, because if you're putting in all that effort and energy, human energy has value, not just economic value.
I take
value.
the same on design, like if we look at the world, nature designed, all the trees, it designed, the earth structure, it designed all these things. And humans come along and they do what they design. And most of it, for the large part, is fairly poorly designed because our education isn't sort of holistically attached to it. When we build it, it costs the same or more to build the same project, whether it's just a shit design, whether the circulation of it's bad, whether the light comes in poorly, if we're building a wall and a wall and a wall and a roof and a floor, how we build that, orient it, what we do with it, good or bad, dies with the pencil that creates it, like it could just be a shit design, poorly designed for the environment, poorly designed for its space. We tend to go, oh, we're in Phoenix, and why wouldn't we build a house like that in Florida? Or, it's of a region for a reason.
Yeah.
And there's a lot of cues to why it's of a region of a style and a way from the region. And not everything is transportable. We have different climate control zones and pieces. So I'm a big one of design's got to be right for its place first. And then we start from there, and then we go, okay, what do we need in the materiality?
Yeah.
Yeah. So whether it's well built or badly built.
Yeah, it's almost similar types of energy, similar types of money, similar types of time. All those things. Like, why not just spend a little extra everywhere and build a phenomenal building that's outstanding, rather than a mediocre or a crap building?
Because we only have to make a building that lasts 50 years, and people think that means that it should be cheap. And I'm not saying it shouldn't be the most cost effective for the value that it delivers. It should be. That's part of being a designer. How do we make the most cost effective outcome for the delivery that we're going to get? The issue to me is that it's a bit like the clothing industry. We all want a new shirt and new shoes and whatever else. Our houses don't carry the core that is, well, they shouldn't say they don't. They don't have that historic thing like maybe in Europe and stuff, where it carries a core that will last for 50, 100, 200, 300, 400, keep going years. Yeah, sure, we want a new kitchen. That's like buying a new pair of jeans, like we need a kitchen, we need a new pair of jeans when we've got holes in the old one. We've got technology that's moved forward. We want to be able to do that. We want to be able to do that in the building. Ideally, that takes very little to alter to accommodate it. We don't have to knock everything down to build something new. What happens if we take what there is and just keep lifting it and renovating it over its lifetime? A lot like happens with a lot of protected buildings, in the UK, US, and up into, obviously, Europe has a lot of that as well. So that's my thinking.
If you look at the expense over the lifespan of a building, and you can really see this in low-cost housing or anything where the costs are tracked through the maintenance and through the longevity of a home or structure of any kind. It is hard to find a more expensive way to build than how we are building today. And that's on a societal level.
Yeah.
So that's, people say, well, it's expensive to do the X, whatever it is, whether it's SIREWALL or whatever it is. And it goes, you are spending so much money not doing that.
Yeah.
For you, for your children, for
health, all of it. I mean, you look at drywall as an example. If I paid you $1 million, you couldn't come up with a worse product than drywall, and we use it everywhere. It's horrific. It will be. Next asbestos. I predict.
Really,
that's my prediction. It's so bad for people.
I look at MDF as well, things like that, where, like it's a lot of glues and stuff. And so then we're getting back into the health and the building biology of it. We're saying, we might have 10% cement in a building that otherwise would be made of a whole bunch of other things that are all gassing off into our little 10% gassing off versus that massive gas off that's happening from all the other things that are in our environment. And why are we in a health crisis in most Western countries, where the conspiracy theory is, obviously it's best to keep us sick so we can keep selling drugs. I don't think that that's possibly quite the real thing, but there's going to be people who are going to argue that. It's that we look at things in little pieces instead of in a holistic manner. And when we start looking at things in a holistic manner, we start making different choices. And my comment earlier about, I think COVID has maybe accelerated people's interest in their own health. And this will be a blip. It'll just be a blip in time. It's nothing in the scheme of things. But it was big enough in a global kind of reaction that it opens the story. I like that about it.
Yeah.
Yes.
Well, it's sort of correlated to organic food, right? Like somewhere along the way, we figured out, putting pesticides and the other crap that goes into those food production into our body doesn't make sense. So now everybody eats organic food, and it costs a little more, but it's now widely available. It took a long time, it took 20 years or whatever to sort of catch on. And I think healthy buildings and healthy building materials will be sort of the same thing, where people start to learn about, why would I want to have an environment that's full of chemicals that I keep my children and my pets and myself in, and create this perfect, this great thermal envelope, like a bubble around me to keep it all in. And I wonder why I'm getting sick, or wonder why my kids have asthma, or wonder why, all those things, right? People, it will catch on, and it is starting to catch on, unfortunately. But that's a big part of what our future is about building healthy buildings and not only healthy for people, but healthy for the environment too.
So,
but
my question my question is, why is rammed earth healthy? Why is this thing better than other things? And we can go, it's been around for thousands of years, all the rest. Yeah, whatever. Why is it healthy today? Why does it make a difference today? Sure. So just a couple of quick things. Joss will jump in on this afterwards, but a couple of quick things is, if you look at drywall, there's about 70 ingredients in drywall. Most of them you don't want to know what they are, and you wouldn't want them in your home and around your children and around your family. In SIREWALL, there's 5 ingredients. And the majority of them, in fact, all of them are inorganic. They're ready, non-toxic. And there's a small amount of Portland cement in there that's sealed in the wall, in the construction of the wall. So, that's just a starting point for, having something that doesn't off-gas and doesn't, not bringing toxic materials into your home or your little bubble that you live in, But then the other aspect of it, or one of the big aspects that we're now exploring and working with doctors who deal with people with mold and a condition called SIRS, which is chronic inflammatory response syndrome, which is an autoimmune condition, usually in response to mold, but other things as well. And we work with a lot of the doctors there. That what we knew for a long time, but we didn't know how it applied so well. But what we're now pushing and working on and refining is that rammed earth will take in humidity in the form of water vapor is taken into our walls when there's a humid climate around, or you have humidity in the air, and it will let it out. So it regulates humidity, kind of like it regulates temperature inside with that inside mass and storing a battery. It's also a battery for humidity and can regulate. We've shown and have some testing done that shows we can regulate the humidity of a building to between 40 and 60% humidity, which is not only a very comfortable living environment for human beings, but mold cannot grow below 60% humidity. So it means you can essentially eliminate mold from a living environment. And for people with SIRS and people with other sensitivities, people even without it.
Right. I mean,
yeah,
exactly.
Everyone.
But why wouldn't you want, everyone wants to eat organic food now, right? Of course, everyone wants to live in a healthy building, So you've not only got a non-toxic product in there that's not off-gassing, but you've got something that's now regulating the humidity and basically eliminating mold. You still might get mold, under your kitchen sink or in a microclimate inside a home, which you can regulate that. You can figure out, put on mesh on your cabinet doors or whatever to let that move.
Yeah,
change that, right? But you've created basically a space that's now got exceptional indoor air quality and no mold and non-toxic, depending on what else you do in the building, obviously.
Of course.
You can't put that in and put carpet in, and now you've brought in another thing.
You've put another toxicity into the environment again. Yeah.
So
although in saying that,
yeah,
you're not layering your toxicity as well. You can put carpet in if you want, but you're not layering the toxicity as you go, which again is not looking at something in isolation. It's not just in isolation. It's a holistic environment we're trying to look to live in. Yeah.
So we've now developed like a roofing system that's inorganic that can be used on any building, but we are starting to put them on some of our demonstration homes that we're starting to build and that sort of thing, to create indoor living environments that are completely inorganic to some degree or another, depending on what else you put in them, obviously. But taking all those organics out, which, when organic materials, like drywall, for example, has a paper face on it, which is organic. So as soon as that gypsum gets wet and acts like a sponge and soaks up that water, your paper face is going to mold. So you're going to have issues. So taking all of those kinds of things out and taking all those toxic organic materials out as much as possible creates a healthy living environment. And that's really a big part of our future is about building buildings like that and sort of being the organic food of living building environments.
Absolutely. It's a performance solution, a performance-based solution to health and building.
Can I jump in and elaborate on two things there? The first is Michael was talking about a humidity flywheel. And so the thermal flywheel is, people understand better. It's like if you go lie down on a rock on a beach after it's been sunny, the rock is warm and it radiates through you, even if it's in the evening. That heat is radiating through you. So the thermal flywheel, we understand to some degree as people. The humidity flywheel works the same way, but it requires a material that can absorb the water vapor. So concrete has a temperature high flywheel, but it doesn't have a humidity flywheel. The humidity doesn't absorb into the wall. It will condensate on the wall and run down the face.
Because it's smooth. It's
too smooth.
Finish. Yeah, it won't. So go ahead.
The particulate on the face of the wall is too fine for the humidity vapor to absorb into it.
Right. So with that, we're again enveloping ourselves in a different way.
Yeah, you've created something that can't breathe, as a poor term in design, because it means different things to different people. It's not well defined. So some people think breathe means it needs to breathe from outside to inside. Other people think how I use breathe, or how, I always explain it before I use it, is that it's able to absorb humidity and release humidity.
Yeah.
And it's not really breathing, but it is taking something in and then releasing it. And that is a key attribute to creating a constant humidity in a space. Mold is bad for everyone.
Yeah.
That it is a negative to human health. And if you put data loggers on a typical building and you have a shower, even with a fan on, you'll see the humidity inside that space spike up over 90% relative humidity. And then it'll go down, you're for whatever reason you light a fire or whatever it is, you dry that air. It can go down to 20. Yeah, it can go down to 20%. And if inside the space it's spiking up, down, up, down, up, down, and there's no consistency. And that's when you're in a low humidity environment, you are very susceptible to viruses. So things like COVID, but any virus.
So like where Michael lives, low humidity environment, versus where you live, high humidity environment. Where I live, high humidity environment.
Yeah, exactly. So there's our human bodies perform best in a certain range. And this is well proven. This isn't controversial. So that what we want to do is manage the interior environment to stay in that range, stay in it for temperature, stay in it in humidity, and you create a healthy environment. The other thing I wanted to differentiate from what Michael said was there's two things that impact human health. I simplify it down to two things inside a building. One is the environment, which is what I just described.
Mm-hmm.
And the second one is what is in the air, what are the building materials you're using? What is the sealer that you're using? Lead paint is one that's got a lot of, because it's old enough and people don't use it anymore, people use it as an example. But everything that's around you, it does decompose and you do breathe it. So when Michael's talking about the composition of drywall, or you're talking about MDF, or whatever those, whether it's like
some of our
whether
paints,
it's a paint,
some of everything, right from our light bulbs. Yeah.
And people don't understand that when they're looking at building a healthy home. They'll focus on one thing. They'll focus on, okay, I want to create something that doesn't have these chemicals. But in doing so, they don't focus on humidity in the space. And those chemicals are actually there for a reason. So the reason why we're putting chemicals all over all our wood is because wood rots. Organic materials rot. Yeah. They're designed by nature to decompose. That's what organics are. Mm-hmm. And what we do is we try to toxify them so they don't rot. Mm-hmm. And then when you take out those toxifying agents, now you've created something where you don't have these chemicals, but you've created an environment that will decompose.
In saying that, we've had some successes with, things like a Boda wood and, where these pressure treated, in vinegars and stuff like that, woods, where they last. I don't know what their off-gassing is for them, but they certainly, that part of the industry has changed a lot and what it can do, not what it does do, what it can do. Because in general, it's still done, maybe not the poorest way it's ever been done. In the last 50 years, it's probably changed a fair bit, but it's still coming from the premise of the drug kind of company premise of we'll just make the cocktail different to get the same result.
Well, and that's what the general consumer is fighting, because they focus on what they know, as they should. And the EPA, who tests all the chemicals that are in the US market, or is supposed to, they don't. They test, this is old data, so I'm sure the numbers are going to be wrong, but the premise stays constant. They were testing about 10 chemicals per year. And there were thousands and thousands of new ones coming onto the market every year. So that is our safety to to create human health. Yes, we can identify that something is toxic, but a manufacturer that can find going back to paint, and the measurement there is VOCs that gets used for health, where you can create a no VOC product that is very nasty for your health. Mm-hmm. People think because it says no VOC, it's healthy. It's not. What has happened is a chemical agent, the chemical company, it might be healthy. I can't say it's not healthy. No. But it's untested, and it's not a known VOC by the EPA. That's what it's telling you.
Yeah, right. That's kind of scary in itself. But one of the things, I've had a few building biologists on the show, and I have a fascination with the building biology part of it. One of them is Paula Baker Laporte, and
cool.
We know her well.
Know her well. Yeah, she's a fabulous human.
Yes,
with all the right. With all the right, again, vision for what the built environment can be. And with that, the health, there you go. Yeah, a recipe for a healthy house. Yeah, just absolutely amazing, like that whole thing about conscious design, beyond conscious design, conscious material choice, and then also environmentally appropriate. I don't like the word appropriate. It sounds like the least that you're putting into it, but whatever more than appropriate is, the least for the best for the human, the best for the environment, the best for the when I say the environment, the immediate environment of where that home might be as well. And I want to go, like, there's things like the passive house movement, this, which I think's amazing. With that, I have a lot of people say to me, "Oh, passive house where I live." Well, where I live, the temperature variation's tiny. It is humid. It's damp. It's kind of a bit like Florida in places. It's dry in the summer. It's dry in the winter and wet in the summer. It doesn't get it does get cold, but it doesn't, like, it's not extreme. We live with our house fully open for, I don't know, 9 months of the year. There's doors that don't close unless there's a massive wind or massive rain. The humidity in the house spikes like unbelievably, and then drops back down to, be very low in the winter months. We don't live in a highly toxic area. Like, it's not like we have a freeway or a motorway just right in front of us or anything. We still have toxins. We have a lot of trees, so we have a lot of dust from that. We're not going to cocoon ourselves into this built thing. We're going to live with it wide open. The air's going to come on one side and go out the other side. We do get mold. We don't get extremes of mold because we have so much air shifting around, but we still get mold because, the house isn't perfectly designed. It's got pitched roofs inside. It's got beams and stuff. So there are spaces where mold can get a foothold. So it needs to be cleaned, like most things. But that whole thing of we can create a sealed environment that we live cocooned in versus an environment that is part of the nature that we're seeking to, that we deal with when we go outside. Like, it's one thing, I live in this, not me, but somebody lives in, say, a passive house, and then they walk outside and now their body goes through this massive environmental extreme. So it's got to do this quick adjustment. It's got to go from this to this. And then, I'm not saying that that's bad. I'm just saying that's what has to happen. And then our tolerances for things become more highlighted because of the quick extreme. Whereas we design houses here, where I am in this region, to be open. And so then rammed earth, I kind of see it, and I could be very wrong, as an extension of the outside, just becoming a part of the inside. And as that humidity outside shifts, so does it inside. And we're living closer to what our environment is, as opposed to a forced environment. But then, Michael's in Phoenix, where there are lots of parts when you just want to get that thing chilled down. I took the air conditioning out of our house and added different windows, and it's a renovation, different windows and different breathing through the home so that we didn't have air conditioning. And there's a few uncomfortable days, but not many. And we've designed plenty of houses where they don't use their air conditioning because we're cross-breezing, where, the mindfulness of our roof shapes, our window placements, all the things that make a house work. Is in the design, not necessarily in, it is in the construction as well, but it's in both those things, appropriate for its environment.
What you're describing is ideal. If you can work with nature, that's, and nature is supporting you, then that's ideal. What you're describing is also a very small percentage of the planet. And that, for most places on the planet, there is a portion of the season or the calendar that is comfortable, where you can use passive airflow and work with nature. And I should take a step back. Before we get into climate, there's outdoor contaminants. A lot of places we need to make our indoor space healthier than our outdoor space. Because we're in Phoenix, there's so much smog. The air quality is so poor. We've worked in Shanghai, there are a lot of places that are not even in major cities, but because the air comes from a certain place, they get air from China and California, where they're getting smog and contaminants. In
Thought they had their own.
Well, they do. I'm not saying they're doing it perfect.
They definitely do.
But you could live in the middle of the forest and have need to escape from the outdoor air. And that's unfortunate, but that's where we are as a society. So what you're describing, what I would strongly push is that people check what the air quality is in the region and do tests. It's not that expensive to do tests on air quality, so that they understand what is suitable design for that climate. And then, if as much as you can do the passive ventilation and cooling and heating and living with nature, the better. But in most climates, you might have that for a portion of the year, but the other portion of the year, you want to be able to close that off. Say it gets down to very cold, so you want to be able to close that off and have a sealed unit. If you don't have a sealed unit, you're pumping AC through there in Phoenix or the surrounding area where you're not dealing with the smog. You're still pumping AC through there trying to cool it down. And because you've created a building that is working with nature in the winter months in Phoenix, then your building isn't built to be able to perform that way.
Yeah.
So what you want in that climate is to be able to do both.
Yeah.
You want to be able to open it up when the climate allows,
Mm-hmm.
but you also want to be able to seal it and create a healthy indoor environment, which I'll go back to Phoenix again. Phoenix has a huge issue with mold. You wouldn't think it because it's a dry climate.
Yeah.
And Michael can speak more to that, but the amount of
that's a problem.
It's because of the performance of the buildings, because they are so open and they have that air.
That desert scape buildings that you open up. Yep.
Yeah. And then they're creating AC and you get condensation, and that condensation, when you're blowing cold air everywhere, creates mold pockets, and it'll always find the place. It'll always find somewhere to condensate, and it will always create mold.
Yeah, and not to mention just the heat that we have, the amount of heat that we have. If you trap that heat and have a small leak somewhere, you've got mold like that. I mean, it's just it happens very, very quickly here.
Yeah, right. And as I say, I would have thought that it was, one of the least environments for it. Whereas I would have gone, take me to Florida or take me to the Ozarks or somewhere like that where you've got these high, up in Minnesota and stuff, where you've got these high humidity environments where we kind of just expect to get mold. So if you take rammed earth and you go put it in the environment, and just so, because it's pretty, I can't do the calculation here, but like 40 degrees is extremely hot for us. Zero's freezing. We probably maybe get 1 or 2 40-degree days in a year. We get maybe 1 or 2 6-degree days in a year as well, but nothing sustained at that.
Yeah.
And then, but we'll go from 99% humidity, like in the summer months, and then in the winter months will be quite dry. Suddenly, I know this from traveling and living overseas and stuff. Suddenly your lips are cracking, and like when it dries out, or your nose will bleed or whatever because it dries out so much. Versus here, you can just about always, that never happens. Like, doesn't get to either extreme. So then take rammed earth in this environment and take it in SIREWALL construction. What happens?
So your danger, before we get into SIREWALL, Mike, you know your climate better than I do. So I'm just going to hypothesize, and you can correct me if I'm wrong. So where you're dealing with issues is in the summer months where you get up to 40 degrees and you go, it's too hot outside, I need to close this up. But it's 99%, 90% humidity outside. And that's when you're running into mold issues. Is that accurate?
Yeah, in our case, we don't even close it up because we don't have any aircon. So we'll put fans on, but we'll go if it gets that hot, go to the movies, go to the mall or something. There's always somewhere cooler, like there's somewhere cooler. But like in most of our clients' homes, they would go, great, close everything now, and then we'll bang the AC on. But that might only be for a very short period of time, if at all,
Yeah. So what I would suggest, and I would want to talk to a building envelope, like I'd want to talk to someone locally, because my expertise is SIREWALL. And I have I understand health, I understand environmental. Yeah, I do have some understanding that I've pulled from experts over the years, but I don't, doesn't mean I am the expert. So ideal would be in your climate that you're willing to accept living in that temperature and have it be open and have something with mass, so that, and mass, it might just be wood beams, something that can absorb humidity and minimize the risk of that humidity pooling in that
Gotcha.
Creating something that can absorb that humidity, and in those small windows where the humidity skyrockets.
Gotcha.
And the temperature's too hot.
Yeah.
So that your porous materials, if you're creating a plastic bag, which is how our building codes require us to live, you don't have those materials typically. Drywall is painted drywall, you're not absorbing anything.
Yeah.
So that's that's the issue. You want in that climate something that can just give you a little leeway. Because you're in such an ideal climate, you want something that can absorb that humidity and give you a little leeway so that you can work with nature.
Yeah.
I do also, because we're on a podcast and this is going out to all different regions, it's really important to emphasize that you're in like the 1% location on the planet where that's possible.
Hence I live here. Yeah.
Yeah.
Hence I live here, like
most places aren't like your clients, even where you are, they're not willing to accept that outdoor, assuming that the outdoor air quality is good. They're not willing to accept.
Yeah. Even here, a lot of people aren't willing to accept that, to live that close to nature. And so if we were to build in this environment a rammed earth house, it would be absorbing, that moisture out of the air, and then it would be expelling it back in as required.
Yeah.
We would have a healthier environment. We know that. We can still live with it open. It's not going to make any difference. We can close it up, and we can it will still release that moisture over time while it's closed up. And then our environment will be, maintain that healthiness of it. I look at our bigger problems being for our environment is the amount of organic stuff that comes into our environment being fully open. But, like if we were cavemen, that's what we'd be living with anyway. So, you're going to get dust. We can't stop any of those things. There's no point in trying to. There's not putting ourselves in harm's way, but then our environments are going to dictate what we do. I mean, I always think of...
Absolutely. Yeah, you will get the natural, like, if we were cavemen, sure, we'd be dealing with dust and some things, occasionally there'd be a fire or whatever and some of that. But these days, what's getting pumped in is, exhaust from cars and factories and, monster fires and the health issues that come with that sort of toxic.
I look at the LA fires, so you burn down a massive amount of, let's say, forest. That's one kind of toxicity. You burn down a shitstorm of chemicals, and all individually mixed together. We've got this incredible cocktail, and all that from all those houses that are burnt, from PVCs to glues to, timbers to arsenic to, formaldehydes to all these different chemicals that have been burnt. That's all gone somewhere, and that's all going back into the system at some point, with hopefully the system can be big enough to filter it. But, as you said, Joss, there's stuff from China that's happening that's in the forest in, California or wherever. It's one system. It's one system and how fast it gets round. So if we take a piece of the system and if we go to living with rammed earth, we get to it just in the physical piece of it. We get to actually regulate that temperature in our homes a whole lot better. We get to let our walls breathe with us. And then the other things that I know from it is it feels very different, like very, very different. And that's a feeling. And beyond it just feeling different, it's got a sense of a calmness in it as well, that maybe the weight of it drops your sympathetic nervous system down a bit. It also has a lot of sound, takes care of a lot of sound pollution, which I think is one of our biggest pollutants, is sound. So it's taking that out of our environment as well.
Electromagnetic
that was my next one.
You can go into lots and lots of stuff like that. Yeah, and SIREWALL takes care of a lot of those sorts of things, and rammed earth in general. Degree.
And then with that, then you go, if we had more homes that were built with it, maybe in its entirety, but at least in part, we gain a whole lot of benefit from that. Like if we have a home that is, say, maybe drywall for 50% and 50% that is rammed earth, the rammed earth will work harder, but it will still do its job. It comes in and does its job.
Yeah, it depends how your airflow is in your microclimates. You can your drywall is extremely susceptible, but the rammed earth will greatly outperform if you didn't have the rammed earth. So it's a complicated question.
Yeah, and sorry, go.
The other thing, you just in terms of just, I have a example of people, the feeling that you get, that living with it and that. So that big house that I built, in Arizona, that's massive. It has everything that's perfect, I mean, they have $1 million sound system. They have all these things in there that, the countertops are perfect, the cabinets, everything. And I know the property manager quite well. And he tells me when people visit the house that they ignore all of those perfection things, all those things. The paving's all perfect. Everything's done everything's garden, just perfect even. They all go straight to the firewalls and they touch them and they ooh and ah over them because it's the only organic thing in the house. It's art. It's like living with something organic, that not organic in the sense of the materiality, but the look of it, the feel of it, the
energy it gives off. Yeah.
The energy, there's something special about it that is really unique, and every part of every wall is unique. And so there's something about that, just going back to what you were saying about the feeling of it and how that is for people. There is something there. It's a very attractive material and a very calming, very, and Joss can talk about positive and negative ions and that sort of stuff better than I can, but there are studies, there are things that can be pointed to in why it is that way. Mm-hmm. But a large part of it, I think, is just the way it looks, the way it,
it's visual impact and it's the sound impact and all those things certainly have a massive thing. I did a podcast recently with a lady called Andrea Knowles, and then she does equine residences all around the world. She is the kind of world's expert in making equine residences. And we had an amazing discussion. And then when I was talking to Mercedes, I'm saying to Mercedes, so Mercedes, what happens when you put a horse, or I think I started with an animal. What happens for an animal's behavior when it lives in rammed earth? And she was like, "Oh, it's a good question. I don't know. Like, no, they haven't complained." But then
I can answer.
Yeah, I'm really keen to understand more about it. And then also I want to look at that and go, and whether there's data or not, don't know. But, when we've got people that are living on the spectrum and whether it has some kind of effect, tell me more, like, with those kind of things, because again, it's part of our societal thing. So what other observations do we have, whether they're medical or hard data yet, or what's being studied?
I actually need to jump off here in a minute, Adrian, so I'm going to let Joss take, and I will jump off here in a sec. But
awesome, buddy. Great. I'm looking forward to catching up in the US with you, and we'll do that for sure. Yeah. I do some architectural tours, which we call them feast experiences. So they're about food and architecture and digging into things like we're saying, and talking about these kind of things and taking people on adventures of those things. So we will hook up on one of them.
Like that. Yeah, we're all about. We love that sort of stuff. So
I'm sure but Taliesin's not far from where Michael Frank Lloyd Wright's Taliesin.
I did a little tour 2 years ago, I think it was. Just a couple of architects and myself. We took a small plane from Austin, went up to Midland, and then from Midland we went to Santa Fe, and in Santa Fe we went and visited Rick Joy, and we also visited Dust DB, which is Cade and Jesus from Dust Architecture. We went and hung with them. We in Santa Fe we didn't. In Santa Fe we went and saw a Scoria-based house that the guys from Dust had created. And then we flew back to Tucson and we went and hung with those guys. And then from Tucson, we flew up to Scottsdale and we went and did Taliesin, and then we visited Chen Suchat Architecture as well. We were planning Mark Ryan, but we didn't get to see him just because our timing got screwed up with some snowstorms and things. That we got caught in Santa Fe, so we missed a couple of our things, and then we flew out to LA from there and just did these particular studios and visited sites that we wanted to visit, and some specific site visits and construction sites and homes. So that's the kind of thing that we do. But those ones we do on a very, very small basis, where the bigger tours, we might do 12, 16 people. They're still small boutique tours, but 12, 16 people. And then we might have event pieces where it might have 100 people at it, just different parts of it. We'll be doing like some of that tours together. Yeah, they are. They're really cool.
That'd be great. That'd be great.
For sure.
I'm going to sign off.
Okay.
Thank you.
And I'll talk to you when you're coming to Australia as well. We'll talk about some stuff there. I'll talk soon.
Yeah, I'm planning on being there at the beginning of March. So
perfect. Okay, cool.
Right.
Cheers, man.
Thank you.
Thank you.
Yes.
So you were asking before, you were asking about animals and their environment and the impact that has.
Any of that, as I say, like with the people living on the spectrum, animals are often a first responder to environment. They adapt, but they also, their behavior is often very quick to be seen. And what came out of our conversation originally with Mercedes was, and when I'd been talking to Andrea about, you're creating these stables and big, these big complexes, and we were talking about the health in those areas, like air health and those things. Talking to Mercedes like a few weeks later, and I'm like, hold on a second. Horses are flight animals, those things live with a nervous system that's clocked. Does rammed earth make a difference? But, there you go. That's my question. What does it do for a dog? Sure. What does it do? Cats can sleep anywhere, but what does it do for animals? Birds, even indoors, all these things, like what happens? And if we were creating, people spend millions and millions of dollars on horses and equine things. I go, what are we missing that we could be adding to that environment?
And I like how you've connected the animal question with the human experience and people that are on the spectrum, or because we are animals, and we originated with a lot of the unconscious awareness of our surroundings that other animals still have.
Yeah.
And we struggle as people to speak to that. It's something that we know has an impact, but when we're talking about how does something feel, or what's the impact of our surroundings, there are some things that we can understand, like going and walking by the oceans and the waves hitting the beach, or going and camping in nature. And there's things that we understand have an impact on us, but we don't have the language that people who live in the jungle to quantify that impact. So I'll answer you as best I can, but I also don't have the language to
I appreciate that
impact.
It's more just to get, in my case, I don't think many people have the answers to this, or even how it's being looked at. And I go, it's certainly a factor that we should be, or that we know that we have to discover. We have to discover more.
And what you're speaking to is biobiology. And that's the term. It's a German training, and it's measuring the invisible world. And there's EMFs, there's geomagnetic coupling, there's the chemicals around us, there's negative, positive ions, there's all types of factors, and they quantify as best as they can. They have all tens of thousands, hundreds of thousands of dollars worth of equipment to measure those things.
Yeah. So
if someone wants to go down a rabbit hole and speak to an expert that's way more knowledgeable than me, that's the field.
Go there.
Yeah. My dad started as a design build firm, general contractor and designer on Salt Spring Island. And there's practices that we developed and it's through his research in the environment and that passion of his. And there's things like geomagnetic coupling. And there's an exercise that he did at one point was he carried a compass around with him to jobs. And it was him trying to retrain his brain because we used to be able to migrate. People used to know where they were on the planet. And they used to be a migratory.
They're not following the blue line. They weren't following the Google line. Yeah.
Yeah. So that is how we developed. And the other thing that he often tried to get reconnected with was the humidity in a space. So we can often tell, okay, it feels like it's 16 degrees Celsius, or it feels like it's 24 degrees Celsius. And we're okay at that as people. We're horrible at telling what the humidity is in a space.
Yeah, I'm either sweating or not.
Yeah. Yeah. And if it's dry, you don't feel like you're sweating, even though you are.
Yeah.
Yeah. So we're really poor at that. So these are two things that he was exploring with and trying to retrain his body, and whether that's possible or not. I mean, he was seeing improvement, but in his ability
consciously
to assess
aware.
that.
Yeah, a conscious awareness of like you're putting your conscious mind and your subconscious mind, into having an understanding or into trying to gain more. So something will change, whether it means that suddenly you become this other being that, can do something. But I take, for example, Wim Hof, the Iceman, and you think that his body was built that way? Yeah, maybe partly. Do you think he's trained, I don't know how many thousands of other people to be conscious around these things and the breathing techniques and all the rest? And you go, yeah, maybe we can get closer if we just put our mind to it.
Yeah, there's a lot of things the human body and mind are capable of that, we're very narrow vision there. So I'm going to go back. I started a tangent. My father was going around. My father was going around with a compass, and he'd take it inside a building. And this wasn't why he was going around with the compass. He was trying to retrain his, his connection to,
where north was always, or where,
yeah. But he'd take it into a building, and it would point in one direction, and you'd spin it around. And what was happening was the needle was pointing down at the steel on the floor. Or it would, in one house, it just started spinning.
Yeah, right.
And it was a wiring issue in the house.
Yeah.
And so all these things, you can read it on the on the technology. We don't know exactly the impact that has on humanity, but we developed a system where we didn't put steel in our concrete floors, in our footings underneath the building. There was still steel in the
footings under the walls, but not in the slab.
But nothing in the slab. And the thought process is reconnecting as much as possible to how we originated on the planet, and that is the healthiest thing we can do as people. So there's two steps. One is just that being the philosophy, where how do we eliminate the toxins around us? How do we reconnect to the environment that we developed in, that we evolved in? And then the second approach is, what impact is that having? And that's the way more difficult thing to quantify. We don't know. We know that if you put a magnet on the back of a homing pigeon, it can't find its way home.
Really?
Yeah. It's geomagnetic coupling is something that we have in our brains, and a pigeon also has it in its brain. And if you are putting these types of things around you, you are losing that ability.
Thank God for my mobile phone, It's keeping me safe.
We're definitely doing those things to us. I have Bluetooth speakers on right now. I understand that that's having a negative effect. I don't know what the negative effect is. There's lots of studies on cancer, and you can go down that rabbit hole, and I have. And you get to pick your battles. And so there's that philosophy piece, which I wanted to start with in answer to your question. And then this as far as animals, people come into our buildings and they'll have a sleep. This is an experiential, and they'll go, I haven't slept like that in decades. Like, I haven't slept like that since I was a kid. And we get those kinds of feedbacks all the time. And environment has a huge impact on how we experience life. And there's things that we can quantify, like positive ions, negative ions. And I have a wood desk in front of me. This one's emitting negative ions. The one right in front of me had some kind of sealer on it, and I haven't measured it, but I promise you it's emitting positive ions because it now has been plasticized. And that has negative ions give us energy. They give us a calmness, and positive ions create an anxiousness that we see in people on the spectrum. And so this negative ion, positive ion is one impact. The invisible world of geomagnetic coupling is another impact. Electromagnetic fields, Wi-Fi, all of these things I go on a hike. We live on an island, and I'll go on a hike and I'll start to feel the hair stand up on my back and I'll feel agitated and I won't know why. And I just, I'm uncomfortable in my own skin and I don't know what's going on. And then I walk over the hill and I see a cell tower. We have this experiential, we may not connect it to what's going on, but we have this experiential response.
I'm 100% with you. I have a process that I've developed, and again, go back to your father's experience of, just trying to work out where you are on the planet. I have a process that I've developed with some other friends of mine who are architects, which we call land whispering. And in doing that, I don't know whether you've ever come across the Silver method, Jose Silva, which is about having the ability at will to switch on your alpha brain waves. They're always there, but putting them at the forefront. And so in part of my process is switching on those alpha brain waves when I go to land. This is very deliberate, like a very, very deliberate process. So if I'm just like you, if I'm walking away, wandering through the forest, I love the mountains. I love like being in nature. With that, when I'm walking around, I'm very conscious of those feelings. When I feel a piece, I start to go, okay, cool, what's happening? Because I want to analyze. I want to understand it better and better. And I look at kids, if you give them a big piece of land to play on, they will gravitate to certain areas. There's certain, whether it's geomagnetic or whatever, I don't know, but there's certain things that they gravitate towards. Sometimes it could just be mud and water and things like that. But there you will find also, I bet you, with your ions, that you'll have a shift in these ions. So I call it land whispering, and there's a lot of just, hard fact stuff about what's our environment, where should the wind come from, what's happening with this space, where do the birds fly from, which way do they go, all these things that we want to discover about a piece of land before we go, okay, we're going to stick a house on it. Because when we stick a house on it, we're going to alter all that structure. And then also going back to, a Frank Lloyd Wright thing of building adjacent to these beautiful spots, don't necessarily build on them. You keep them, keep these pieces. So often we will have a discussion where it's like, they'll gravitate to a piece on the land of some sort of thing. And if the fire zones and flood zones and everything else say, look, you can build here, then we're looking for the best opportunity within that. And then we're doing that next depth of the land whispering where we're going, okay, switch on your alpha brain waves and feel this land, walk around it on bare feet. Here we've got to watch out for ants and all sorts of crap. But I do that. And just be with the land, just be, ask the land to talk to it, ask it to talk to you. I know it doesn't come back and tell me stories, but it does give me energy. And with that energy is like, where does it feel, where feels best? Why does it feel best? What does our structure, how does it respond to the environment here as we're going to create something? And we want to maintain the best energies that we can. And I take my clients on walks like that as well, after I've walked it, and look and watch and see how they react. If they've got kids, I'll get their kids there. We do it sometimes before sun up and into, sundown and waking up, going to sleep, all these different pieces. Because once we alter it, we alter it. We can't take it back. We've done our damage. So in that respect, I'm very mindful of it. And I'm just listening to a podcast on, whether you listen to Rick Rubin on podcasts, but Rick Rubin, the music guy, I can't even say it, Tamagetra, whatever it is, his podcast. Anyway, he has a lady on there called Kai Dickens, who is listening to her one at the moment, so I haven't listened to it all. She is talking about non-speaking, non-verbal people. And one of the examples she gives is of a kid that if they bring any geo rocks into the home, the kid will find them in seconds, like knows exactly where they are, knows whether they're good energy or bad energy, what kind of radiating whatever. But come home from school and there'll be a new rock in the house and we'll go just straight to that rock. You could hide it in the cupboard, you could bury it in the garden, the kid will go to the rock because it's working on a different consciousness level by being on the spectrum. And so then I start looking at this and I go, what could rammed earth be bringing to everybody? And what could it also be adding to those people who outside of our societal norm and our horses and dogs and cats?
So there's a peacefulness that definitely gets communicated. And you see it in the animals the dogs that come into a space. And you can put them into if you want to see dogs relax, like you turn off your Wi-Fi, turn off your power, have a power outage. For me, I go through my initial withdrawal because I live on technology. I do try to spend time in nature and I do it regularly, but the reality is before I can relax, every time the power goes out, I have, anxious response. And then as soon as that passes, it is so peaceful. I'm talking about technology and I'm collapsing the two, but people express that same experience that I feel when technology isn't constantly radiating at me, with our homes. And that calmness, you see it in kids who are on the spectrum way more than you do with normal people, or not normal. That's horrible.
Yeah, no, I know what you mean. Yeah.
With the
norm, with the general population. Yeah.
So that is a visual, like every time you see that, and you see the same thing outside. Like if water is stagnant in an area, people's energy is different than if water is flowing. Mm-hmm. And we've measured that now, where the energy of water is different when it's in movement than when it's stagnant. And that's something where when we're buying land or choosing to live on land, whether you're buying it or not, that land has energy, and some of it is quantifiable. And there are pieces of land on this island that I live on where there's suicides, there's
bad land,
there's abuse. It's bad land. Like, mm-hmm. and sometimes it's cheap because a horrible thing has happened. And it's like, I get the pull, but look at the history of this land. Bad things happen on this land. Mm-hmm. Those aren't bad people.
And you go from that to a lot of our native cultures. Certainly, in New Zealand, the Maori people, and in Australia, mm-hmm. First Nations people, in America, your Native Indian cultures, same in Canada, your indigenous cultures there. They, in general, come from a much closer history than we do of not understanding your land as your survival. It's survival, which is like 90%, and then 10% thrive, whereas the royal we, certainly, we're removed from a lot of that. We've made our survival out of our built structures and things like that. They will tell you constantly, you don't go to this space, and it's just more land, and then they will have legend or stories that explain to multi-generations of their own people why you don't go to this space. They don't call it about energy. They will say, well, these things happened here, or these things are from this. These things are, I certainly know from my growing up in New Zealand with the Maori culture, where they go, this is sacred space. This is sacred, but you don't go there space. It's sacred. We've made it sacred so you keep away because it's bad land, or it's good land, or it's whatever. So it all definitely has an energy to it, and that energy permeates what happens on it. And I think we can add to that energy as well. We can accelerate it by how we behave, the depth of behavior we have on it.
Yeah, I agree.
I find fascinating. I think that more women are in touch with it than men, and that's probably a big, broad statement.
Yeah.
One of my friends, Alan Pease, who's a body language expert, he often would say to me, like, the skin on a woman's neck, face, etc., is thinner than on a man's, and genetically we have grown that way because men would go long distance, do all that, lots more outdoor, where women would be bringing up kids and stuff, and they'd be in some sort of shelter, and so we've developed that way. And one tiny piece of it, and then we have like the diffused awareness that women have as well, where they have the ability to multitask more than men, whether that's a learnt skill or it's an innate skill. We'll go that it's innate, And that is so that they keep the next generation alive. And so he would explain it like they need to be able to feel a temperature shift. They need to be able to hear a noise shift. They need to be able to hear any of those predatory things that could shift, that could be alerting them to keeping that next generation alive. Men are far more likely to, if they recognize it, step into it and go to war with it or move away from it or build a shelter or whatever it is. Women more intrinsically attached to it, and even in their physiology they are. And that makes a difference to them being aware of their space better often than men, and their feeling that they get from a space. We've all had it where, you have a woman with you and she goes, there's something off about that. There's something not right then. No, it doesn't feel good. Yeah, well, what are you talking about? I don't know, but it's not right. And a woman's intuition, I would always suggest people, listen, listen intently and make your decision from there, because their bodies are tuned to a different frequency to get different information than we get. And whether we can develop it and cross-pollinate it, I'm sure we can. Just, there's a story in it.
Yeah, I'm not sure. I don't know whether it's experiential, whether it's something that we can adapt. I mean, what you're pointing to, it's a generalization, but and in general, I find that accurate. Men tend to be straight line, linear. I'm going to go do the thing.
Yeah.
And then after I do that thing, I do the next thing.
Yeah.
And we in our society have diminished women, and again, very general, but we've diminished the slowing down consciousness of what's happening around. We devalue that in our society. And that is a much more connected approach to nature, and I don't know whether it's genetically women are like this and men are like this. I have no idea. It's not my expertise, but there is that connection to nature, and experiential awareness is a much stronger guide than only being able to do the next thing in front of you.
Yeah.
Or not being able to, but that is, for myself, I see it too. And I see my wife is, she is much more willing to, look at crystals or what's the experiential impact of this. And, I've gained an appreciation for that, but it's not my automatic pull. Whereas, and because it is controversial, or it's actually hard for women. Yeah. It's hard for women to express that. They're actually, because they can't put it into words and they can't say why it's having an impact. It's part of I think it's part of the devaluing of women and that belief structure in our society.
Yeah, I think it's something that's just been pushed to the side, a lot. And maybe because it's been, we've had a reasonably male-dominated environment for the last couple of 100 years, but then go back beyond that, and it probably is quite different.
Probably.
It's fairly small in the situational distance that it's traveled, but it's what we experience now. And I think that we have a much more awareness, not so much just gender focused, but there's a growing consciousness around it. And with that growing consciousness around it, the rise of what I call feminine energy, as opposed to whether that being a male or a female, but the rise of feminine energy and taking that on, I go, look, there's definitely something that happens with that. And it's definitely a conscious shift that's happened. And I see it happen in architecture as well. And I see it happen with trends. There's lots of things around that. And it's not that we want to necessarily change masculine energy. There's all the place in the world exists for that as well. It's just, how do we start to be conscious of the rise of what feminine energy brings us as well? And that's as I say, it's situational. I think it's a few hundred years old as opposed to, thousands and thousands of years old. Industrial revolution kind of area of everything that shifted around that's probably a massive part of how the world's developed and the zone and the time that we're going to live on it, in this environment.
That masculine energy has created a lot of positive things and amazing things. But I do think that that switch to valuing what you're describing as feminine energy is necessary in our society. That masculine energy is part of what I think has led us to the deterioration of our society.
Undoubtedly. Undoubtedly.
And that I don't look at it as valuing feminine energy more than masculine energy or something like that. I think we're out of balance.
Yeah.
And it's bringing balance back to a society.
Yep, 100% agree. And I think, what masculine energy has done, it's incredible. And if you look at anything over a long period of time, like you just extend the boundaries, you will see that it's a bit like, the fires in LA. It's a blip of something. It's like COVID. It's a blip of something. Over the long term, it's nothing. It's like, and what we tend to do is because we have so much information flow and everything that we have now, we tend to sort of jump onto highlights of things. And I go back to the rammed earth thing and this feeling that it gives you when you live in it, or when you're around it. You don't even have to live in it when it's part of your environment. That it gives you an earthing effect. It does these different things. Whether that's all psychosomatic, who knows? I don't know. But whether it is or isn't, doesn't matter. It happens. And then that peace and calmness that it brings and security that it creates, and the feeling of it shifts who we are chemically as humans. And then as chemically as humans, we get to be able to react differently. Our emotions shift, our hormones shift, all those things. And I think that we'll look back on conversations like this and that have happened for the last, say 50 years, and then in 100 years we'll be going, how did we get so far from where we needed to be? And I think rammed earth will be one of those kind of pieces, this building with earth, building with nature, and letting it breathe with us, letting it do those things is going to go, why did we ever stop?
Yeah, I don't mean to diminish it. I think it is one aspect that can have a profound difference.
Yeah.
And you can have the same impact with light, with sound, with,
if you combine all of them together, then you're really starting to be able to make something, that cocktail, it gets a lot more positiveness in it. And that's, Paula Baker-Laporte sort of style stuff, and Cotter and those people who I hang out with, where I go, they are very consciously aware of how to make a difference with the choices they're making. And from that, we've got, and when I last spoke to Paula last year, we were talking about the fact her book, her sales have gone through the roof and all the rest. And I said, why? And she said, well, during COVID, she was on a fairly controversial podcast. And this podcast is listened to by lots and lots of what we'd call biohackers. And they were like, right, okay, so we need to shift our living environment. It was like a light came on, that the actual living environment that they were in was actually not going to support everything else they were doing to live with a better health span and lifespan. And most of them are looking for a health span and a lifespan. And then what did they need to shift in their living environment to do that?
Yeah. Yeah. And what I feel passionate about, and what I'm a visionary. I love seeing, picturing the future and what world do I want to live into. And if you can create an environment where SIREWALL is the shell, and you've created this for people to, and this is taking on my father's vision of how can we live on this planet the best? How can I do the best? And for me, that's just a beautiful building block to start with, where you have something that you're still have your connection to nature. You have material that you're connecting with that's providing you peace. And then from there, you can amplify the impact of people, whether they're dealing with SIRS or autoimmune fibromyalgia or whatever the health issues they're dealing with, or whether they're on the spectrum, or, you can take that as just a building block.
Yeah.
And then play with light and play with sound and play with, all these different impacts in this space that's clean. I think I'd love if we can be there in 10, 20 years and be learning that about the human consciousness and experience, that
it'd
I'd
be a
love to.
tick. It'd be a tick. It'd be a lovely thing to be a
Yeah.
part of. Yeah, that's kind of my journey with it as well. Like, how do we start with that, just the land we're going to be on, and then from the land we're going to be on to how can we build better to be on that land? How can we create a better human experience? And then how can we build that, or design and build that we make things that are there for a long time, not 50 years. We want them there for 50. We want them well longer than 50. How can we put that value into something that, I want to say, almost like people are scared to change because they're scared of what they'd lose. But that thing where, you know, it sure, it gets modified, it gets all those things, but how do we just work with that? And then one of my good friends in the UK is a guy called Richard Dajitsky, sorry, and he's a passive house specialist, you know, and he always says to me, the most environmental building is the one that's sustainable building is the one that's already built. And I totally go with that. Yeah. So I'm fascinated by it.
That's, I think that's more true in Europe than it is in North America.
Yeah, absolutely.
Yeah.
Joss, I would love to pick up a conversation on this again sometime and talk more about it. It's absolutely brilliant. Thank you so much for all your knowledge and delving into it. I think I'd love to do one where we talk about specifics with building with it as well. Let's hook up and do that again.
I'm happy to let you lead. You let me know.
Cool, man.
We'll go where you want to go.
Awesome. So thank you so much for your time today. Really appreciate it. It's been mind-blowing and brilliant to meeting of the minds. Yeah.
No, I really enjoyed that. I've got some rabbit holes to go down myself from this conversation. So
brilliant. Let's keep the conversation alive. Cheers, man.
Cheers.
Take care.
You too.
Bye. Thank you for tuning into our conversation. I hope it left you both informed and inspired. Don't forget to subscribe wherever you listen, and please don't hesitate to share your design thoughts with me. It's always a joy to hear from you. If you're like me and crave a deeper dive into design thinking, coupled with a love for travel and adventure, consider one of my architectural adventures. Join me and some of my wonderful design friends and embark on a journey of a lifetime. Apply for an unforgettable design experience at adrianramsey.com. With our clients spanning the globe, I firmly believe behind every great project are great people. If you're a great person and seeking to turn your dream into a reality, I'd be honored to design your home with you. Why not join the ranks of our exceptional clients and let's make your heart sing? Reach out to me at studio@ardesignhouse.com. That's studio@ardesignhouse.com, and let's get a conversation going and make your heart sing.